Okay. All right. I think everybody is in place who's going to be here. So let's get started. Well, before we get started, any questions? I should probably do that. Anything you want to see or any questions? I think we just have this implicit differentiation we started, which will lead us to related rates, I think. All right. I guess no questions. All right, here we go. By the way, on this sheet here, I'll be assigning problems from this sheet selectively here as well. Okay. I start with this one here.
When you say selecting problems from the sheet, what are you referring to?
Well, implicit differentiation. I'll share it with you later if you don't have it, but it's on the screen now.
No, I mean, you're going to be picking problems for homework?
Yeah, I'm going to have you try some in class.
Oh, okay.
And I'm going to have you do a couple of them for homework. I'll pick some of the trickier ones out and do those here, and so it won't be a mystery to you, okay? All right, let's start with the first one. I might have to go to my whiteboard. I'm not sure, but I'm going to try to do them right here on the sheet, okay? All right, so this one right here. Now, on these implicit differentiation problems, there are other ways to do these, but I find that if you just go from left to right, just work across the derivatives and then solve for dy dx. It's probably the easiest way to do it. Now, today, I'm going to say y prime instead of dy dx, so I can treat y prime or dy dx like a variable. So it's easier to move it around and isolate it, okay? You may find that easier too. It's just easier than using dy dx. Now let me just back
y prime and dy dx are the same thing, right?
Yes, y prime, dy dx. Let me see if all the things I can remember now. Y prime, dy dx, in terms of y, I'm just trying to get all the ways. I saw another way the other day and I remembered I should probably tell you, but y prime is what we usually see when we're doing implicit differentiation, okay? Because you want to treat it like a variable, Mariah, so you can move it around easier. Dy dx is a little cumbersome, all right? Okay, now when do you need to use y prime? Well, whenever you're taking a derivative of y, of a y term, it's really f of x, so that's when you got to do dy dx. You got to respect it. But it's almost like you take the derivative with the rules, and then you got to remember to put y prime when you're doing y, the y variables. When it's x, you just take the derivative like you've always done. You never said on x squared 2x dy dx. You would never say that. But you would do it when you're differentiating on a y, on a function of y, okay? I think yesterday when I put it on the board, I said f of x, y, because I wanted to let you see there were two variables in these. Now, often they will present like this, okay? And not just all the x's and y's on one side. This is getting you ready for what we call solving for a differential equation. But you can't do that yet because you haven't done integration, but you get the idea. So you start over here and you say, what's the derivative of 2x cubed? All right, okay, Jordana? Derivative of 2x cubed?
4y.
2x cubed?
Oh, wait, 6x squared.
Right. You didn't know you're ahead of me, huh? I like it. Okay. Well, I have you. What about this next term? Now go here. Huh? What'd you say?
4y.
4y. And Bailey, should we add anything to this?
No, because it's 0.
Okay. So you put y prime.
Oh,
Y.
okay. I'm sorry. I thought
Right.
you meant the 5. Yeah.
Right. Now, why do you do that, you might wonder? Because you're differentiating y with respect to x. But when you have an x term there, you don't have to put anything. Like when she did 6x squared, we don't say dx. Nobody does that. But when you differentiate that y, you're going to say y prime. That looks like y to the first power, doesn't it?
Wait, I'm sorry. Why aren't you putting dy dx?
Okay, because I said earlier, you missed it. That y prime is the same thing That's dy dx.
No, I know that. No, I didn't. No, I know. but
Okay, the
I'm just
reason why I'm
asking.
putting dy dx or y prime is because isn't that a y function here?
No, I mean,
Yeah, okay, go ahead. I'm sorry.
I'm sorry. I mean, why aren't you writing dy dx?
Because I don't want to.
Okay.
And the reason
No,
I
I
don't
just
want
remember
to,
from
and the
class.
reason I
it
don't
was-
want to, the reason I don't want to look over here is because it's going to be easier to use a single variable when you solve for y prime. You'll see in a moment, okay? I just don't want to carry around that dy dx. It's too hard to write.
Okay.
And it looks like a division problem.
Okay.
So I'm carrying y prime like they do in the real world, okay? Because they don't want to have to deal with that. Now, you might see it here. So we're going to solve this for y prime. We got to get y prime by itself, like we've been doing in algebra for years, which means we have to divide both sides. I'm going to show how it looks over here. We're going to divide both sides by 4y. And that gives us y prime. I got to remember to put prime, okay? So now we should reduce this to lowest terms. I'll put a comma. And we get 3x squared over 2y. And that's what's equal to y prime. Okay? Because the directions we're finding dy dx. I could say dy dx at the end, but you don't have to. Most professors will say you're right. All right, so that's the answer to this one here. Y prime is equal to, or 3x squared over 2y is equal to y prime.
Does it matter if we simplify or not? Or like,
I would mark you wrong
okay.
because I would think you know how to reduce. That's something from way back. So I would definitely mark that off.
Right. Okay. Thank
And most professors would. In fact, sometimes in the instruction, what you see is use implicit differentiation to find dy and dx in terms of x and y, and then it'll say, please simplify if appropriate. Now, I didn't say that here, but it's kind of understood you're going to simplify. Okay? I'm sure the simplified version would be in the back of the book or in the answer key to this. I don't think there is one. Okay?
Deacon, I had a question.
Yeah, go ahead.
Yesterday you said that these questions should always end in negative x over y. Why? How come?
Oh, that was a parametric equation.
And those are different.
That was a
from-
special case.
Oh, okay.
I think this one here might.
Okay.
Look at the format it's in.
Right. It's probably gonna end in.
Yeah, this one's not in that form. Not really.
Mhm.
There's a cube here, you see?
Okay. Yeah.
See that cube? So it's a little different. I did a special case yesterday of a parametric equation in x squared and y squared. Why did I do it? Because it's a common problem you might see later. I just want to at least give you a hint of it, right? Some professors spend a whole lesson on parametric equations, and you'll learn more about them, but that's because they're going to be in that form, negative something over positive, but not all of them, right? Okay. Anybody else? These are all good questions. I'll make sure I go real slow. When you're doing implicit differentiation, you're better. It feels kind of weird. That's why you go slow. All right. I'm going to clear the screen. I hope you got it in your notes. Okay. I guess everybody's cool. All right. Let's go to this second one, in fact. This one right here. Okay. So this one right here, we again, left to right. All right, Bailey, what about this term here?
6x.
How about the next term, Bailey?
6y.
Continue 6y. Is that your final answer?
6y dy dx or y prime.
Correct. All right. And what do you think that equals if you take the derivative? It's the derivative of 2. Mariah?
0.
0. Right. Now, Jordana, what should we do to solve for y prime? What do you want to do first?
Subtract 6y y prime.
Oh, you want to do it that way? Okay, you can do that. Minus 6y. I wonder why people do that. You solve them for y prime, you know.
Yeah.
Wait, could we would it be easier to divide by y prime or divide by 6y?
Every term?
Oh wait, never mind.
What might be another way to do this, though? That's quicker and to the point.
Subtract.
Anybody? Anybody?
Would you subtract 6x?
Are you asking me or telling me?
I'm telling you, subtract 6x.
Okay. Subtract 6x, I think gets to the point because now you're leaving this term by itself, right? It's one step less. So what do we get? These cancel, and we just go comma to go over here, okay? I'll go up here. I'm doing comma so you can see what's next. So then we have 6y, y prime is equal to minus 6x. Now, Jordana, what should we divide both sides by?
Divide both sides by 6y.
6y. And what does it leave us with for the answer?
Negative x over y.
Well, let's stay with that on the right side. Let's go left to right. What happens over here first?
It's only y prime.
Only y prime, because these cancel. Equals what?
Equals negative x over y.
And there's that what you were talking about yesterday, right?
Yep.
Okay, there you go. And the reason why you get that answer is because it was in that form and these are the same coefficient, correct? Because they canceled when they went over. So y prime is minus x over y in this problem. Okay? All right. Let's do, these are very similar. So I think you ought to do number 3 on your own. Why don't you write that down in your notebook? I think you should be able to do 3 and 4 by yourself. And I'm gonna go to one that's different than these, okay? Right, those 2, 3, and 4 are just like 1 and 2, okay? I'll let you write those down. I'll start again in a few seconds. It was there just like that. We might get a chance to go back and do those while I'm waiting for you or something. Let's look at number 5 because it introduces a new concept. Okay. I mean, the concept is the same all day, but now we're going to bring in the other rules for derivatives, okay? Because all the rules for derivatives still work. We still are going to be looking at product rule, and after all, we're doing a form of the chain rule already. So all those rules are valid. Let's start with number 5. I'll do number 5. Number 5 says 3 times 5, 15, taking the derivative, x squared is equal to, now look at this. That's 3x, I'm sorry, I didn't clear the screen. Okay, let's do that. Let's do that again because I want to really blow this up. So the first term is 15x squared. But then look, you got minus 3xy, right? Watch closely. This is really 2 terms. Here's a term here, and here's a term here. Okay? There are 2 terms. What rule do we use when we have 2 terms like that joined together? Anybody?
Is it product?
Product rule, because there are 2 distinct terms pushed together to make one, right? 2 functions pushed together to make one. So the derivative of the first, I'm going to put it in red, is minus 3 times the second plus the first, 3x, times the derivative of the second. So what's the derivative of y? Anybody want to try that?
Is it 1?
One what? I'm waiting.
1 y prime or dy dx?
30 minutes.
Or no, am I saying it wrong?
Knock it out.
Yes, a little bit. So let me ask you this: what's the derivative of if I just said what's the derivative of 4x? What will you tell me?
Is 4,
Derivative of 7x, what will you tell me?
7.
What's the derivative of, so the derivative of 1y, what would you tell me? 1. 1, right? I'm sorry, 1x.
Yes.
I'm sorry, 1x. You tell me 1, right?
Yeah.
So the derivative of y is 1, but then what do we have to do whenever we take a derivative of a y function?
Add the.
Not
You
add,
don't have to
not
add y
add,
prime?
not add. Don't say I. Don't say add. Multiply what? I think you have the right answer. You said
Y
add.
prime.
There you go. So what is this derivative then of y? So close. 1 what?
Y prime.
Y prime.
One
Yeah, I know you
time?
said. I know you
Why
said
do
it.
you want me to
I
say
know you
that?
said y prime before. I know you did. I heard you, but you said add, and I want to be sure we're precise.
Oh, I didn't mean literally. I just meant like.
I know you
adding,
didn't
I
mean
have to
literally.
do
I'm
the-
correcting. I'm correcting the way you're thinking, so you never get it wrong again. Okay. Okay. Because if you're going real fast, you might put plus. So y prime. Okay. Then what's the derivative of 2? 0. So this is what we have so far that's on the screen. We're not finished because we have to solve for y prime. A good first step to solve for y prime would be to add 3y to both sides. And we get, why am I doing that? To get this by itself. Okay? You've been doing this stuff for years. It just feels weird doing it in calculus, but that's why you were doing it for years, so you could be ready for higher math. 15x squared plus 3y is equal to 3xy prime. Okay? Now we have to solve for y prime. So we're going to divide both sides by 3x. And we get this big old fraction, 15x squared plus 3y over 3x equals y prime. You might wonder, is this simple enough? Well, it depends on how you look at it. It would be okay for me, but you might divide each term by 3x. You might. And if you do that, you get 5x for the first term. Remember, you're dividing these two. Remember, you got to subtract the exponents. And over here, you'd get y over x because you're dividing the 3. And then y over x stays plus equals y prime. There we go. So the only thing introduced that was new here was the product rule. It made us have 2 terms here. Okay. Questions? I'll stop. Because that problem was a little bit longer. Questions? Most of the questions will revolve around. Please do.
You say 15x squared equals negative 3y plus 3xy prime,
Yes.
and you have it circled. Why would it be plus 3x? Why wouldn't it be negative 3x?
Why would it be negative 3x?
No, why is it plus? I thought it would have been negative 3x.
Okay, so derivative of the first, let me make sure, you might be right. Derivative of the first times the second, but yeah, it would be. The first term is minus 3.
Okay.
You're right, it's minus 3. I just missed it. Good, I'm glad you're paying attention to that degree. Good job. So really it's minus, guys. So it'll be a minus, oops. Be a minus here, because it was the first term, because the derivative of the first subsecond plus the first is minus 3x. That's what I think she's saying, right? So then you divide by minus 3x, both sides, right? And that means you're going to have a minus here, right? And you're going to have a minus here. So I missed a minus there. Pretty important. Change the problem. I got to change that one down here now. Because it's divided by minus 3x, everybody. Change the sign. Okay. Thanks, Mariah.
Excuse me, Deacon.
Mhm.
I'm sorry to interrupt. Could you look at your phone really quickly?
Could I look at my phone?
Mm-hmm.
I am now. Who's having a meeting? I'm sorry.
There's always a group of women around 3 o'clock.
The counseling center people.
Yes.
Just ask them if they're from the counseling center. If they say yes, we're not. Where's Kelly?
I don't see Kelly right now.
Kelly does tutoring around 4:30.
Mhm.
In there, just make sure Kelly has somewhere to work. I think she'll come to you probably, and she can use next. What can she use?
Room 13.
She could use 13, right? But yeah, she could. She could use 13 till 5:15. Then she can move back to where the ladies were. So ladies can use that room. Take care of it right away.
Okay, got you.
Okay. All right. Any other questions? All right. Let's try another one. I'll sort of stall a little bit for her. I'm going to start using the whiteboard. I feel too cramped. Okay, guys. So I'm going to have somebody tell me what the problems are. All right. How about number 6? Number 6 looks challenging enough. All right. I'm going to try 6 here. Okay. All right. Number 6. Okay. Let's take it slowly. How about going left to right? What should we write first when we take the derivative? Bailey? Number 6.
0 equals
Cause they're not gonna be like, where were they? Like,
what?
you know,
3
if
plus
she knew I was here, she could've
4x.
I'm probably talking behind you. I can't hear you too well.
Yeah, I know. That's why I wasn't really trying. Okay,
told you, you
3x, 3
3.
plus 4x.
So now I'm going to do product rule. Right?
Okay, I'm sorry, I can't see it.
Derivative of the first is 4x, like you said, times the second. I'll go ahead and do this one. Plus the first, 2x squared, times the derivative of y squared, which is 2y, y prime. Okay? Any questions on that? Any questions on that first? It's the product rule. 2x squared, derivative of the first, times the second, plus the first, times the derivative of the second, which 2y, y prime. This time I got the sign right.
Oh, did you just write it out like the product rule before?
Yes.
Okay.
Derivative of the first times the second, which is y squared, right? Plus the first, 2x squared, times the derivative of the second, which is 2y, y prime. Now we want to solve for y prime. So it'd be good. Jordana, are you back? Is Jordana back?
Not yet. Just helping a student right now.
Okay. Who's that? Somebody answered. I wonder who is that? Was that Mariah? No. Okay.
No.
Somebody said it on the over her computer. All right. So they're going to subtract these two terms from both sides, which means we move them to the other side. Because we're trying to isolate, if you think about it, this term here by itself, because we want to solve for y prime. So what do we get? Minus 3 minus 4xy squared, oops, y squared equals 2x squared. Well, I should have put it over there, but I didn't yet. 2y, y prime. That's good.
So would you not do the power, like 3x plus 2x squared, y squared? You wouldn't do the power rule. You would just automatically.
3x plus
power
2x. Oh, which one would be power rule?
No, I'm saying you wouldn't go in like the original equation. You wouldn't go into doing the power rule. You would just go straight into the product rule, right? from the two.
Right. So we do the product rule. In doing the product rule, we have to use the power rule on 2x squared. Right.
Right. Okay.
It's like we don't go. You could look at it that way, but here's what I want to say. The reason why you're saying 4x is because you're taking the derivative of the first. That's the reason why. Now, what if it had been an e function, right? Would you have used the power rule? No, you would have said e to whatever, right? It depends on what the first term is, what rule you use. This time it was it was an x squared. You're going to see one in a minute where it's not. So yeah, you use the power rule because you're taking the derivative of 2x squared. And that's clearly the power rule. That's why I got 4x. Hope that clarifies. So now I'm looking at this right here, right? I'm gonna leave that alone over here, but I'm gonna look over here and combine these. I get -3 minus 4x squared y equals 4x squared y prime. Notice how I did 2 times 2 and made 4, okay? Now I'm going to divide both sides by the coefficient of y prime, which is all of that, right? So you get -3 minus 4x squared y all over 4x squared y, and that's y prime. There's your answer. Now you'll see in later problems, I'll say, what is it at a certain point? And you'll be able to put an X in. I'll show you those in a minute. So that was number 6. That was number 6. Okay. I'm going to do 8 and 10. 10 is introducing a new concept. 8 is a little more complex than this last one. And then I'll assign probably 7. Oh, no, 9 probably. All right. Any questions? Okay. I'll tell you what, why don't we just do that? I would like for you all to go ahead and try. Everybody work on, Jordana, are you back?
Yes, Deacon, I'm back.
Okay, good. Did they get in okay?
Yep. I told them to just refer any tutors who came to the office.
Right, because Kelly might show up. I don't know if she may not be tutoring today either, so you never know, right?
That's true.
All right, number 5. I want you guys to try number 5 by yourself. Everybody try number 5. I'll give you 5 minutes. I'll call for it at 4:36. Take your time, left to right. I believe you have a product rule in there. On the right side, try that out first. We'll do some practice here while we're at it.
Wait, which one are we doing?
Number 5, it's circled. It's circled on the screen.
Okay. Wait, I thought we already did that one.
Did we?
Um,
Somebody tell me, did we do number 5? I don't think, did we?
I thought so. Maybe not, but I think we did.
Somebody help us. Help. Did we do number 5 already? Oh, nobody's listening to me.
I think we did.
You think we did or you know we did? Look back in your notes.
Yes, we did number 5 already.
All right, good. Then guess what? You guys get to try number 7. It's gonna be a little more of a challenge, but life's a challenge, so try number 7. Got a couple of product rules there. It's gonna be long. Maybe at least get the first line, right? How about that? I'm definitely gonna have to go to the white screen in a minute. Let me print this out. See if I can't print it out. Three x squared y squared equals 4x squared minus 4xy. Long problem, pretty straightforward. Good for a test. Okay, write it down so I can do it. I'm gonna move to the whiteboard after this. Oh yeah, I better move to it. Another minute and a half or so, and you can. There you go. I can stretch out on this board now. X squared y squared equals okay. Anybody finished? No? Okay. Another minute? What do you think, another minute, Bailey?
Yes, please.
Okay. Ask Bailey, got Mariah. That's cool. It's a cool trick. I love it. Give you the 439. It's 437 now. All right, let's go through this one. And you can see where why you weren't able to finish or what any issues where you had. So I'm gonna write it down first. 3x squared y squared is equal to 4x squared minus 4xy. Okay? So that's the way this one looks. Let me move this over a little bit. All right. Everybody ready? I can't see your faces. Are everybody ready for me to start do this problem?
Yes.
All right, here we
Yeah.
go. The derivative, well, I see two terms here, right? The derivative of the first times the second plus the first times the derivative of the second. 2y, y prime. I see what's a little different on this problem. I love it. It's a little different because you have a y prime on both sides. I'll show you how to deal with it. Equals 8x, no need to say x prime, right? Is that right? Yeah, that's right. And there's two terms again. The derivative of the first minus 4 times the second plus the first, which is minus 4x, times the derivative of the second, which is 1y prime. So just y prime. Now I'm going to, on this step, combine these terms together, okay? 6xy squared. Somebody said, why? Why are we doing that? Well, because I know from experience that I have to have the simplest terms on each side in order to do my move things around thing I did. 6xy squared plus 6x squared y prime is equal to 8x minus 4y minus 4x prime, xy prime. So you got to solve for y prime, you got a problem. It's on both sides. So the way you have to handle it is the y prime terms on one side and everything else on the other side. I'm going to say that again two times. You get all the y prime terms on one side, right? The right side, I would say. We can do it either way. It doesn't matter which side, right? You can put them to the left or to the right. All right? We're going to get them all on one side or the other side. Then all the other terms on the opposite side. So in this time today, I don't know why today it's developing this way, but the y prime seems to be on the right today. It could have been over here, so I'm going to do that. So I'm going to leave this alone. This term here, I'm going to leave alone, but I'm moving this one to the other side. So minus 6x squared y prime is what I would do. When you do that, it ends up being like this. This cancels. Get 6xy squared. And I would do these steps one at a time. If you rush, you could make a mistake. Over here, it's going to be now 4 terms. I know you'd see these are similar terms, and that's going to be important in a moment. I know you can see that these two terms here are similar terms, and that's going to become important in a moment, okay? Now I'm going to move.
I have a question.
Yes, go right ahead.
In the third line, the 6xy squared plus 6x squared y
Yes.
prime, in that line, you have it equals 8x minus y minus 4xy prime. Why wouldn't it be 8x minus 4y?
Oh, it's a 4 there, right? That's right.
Okay.
There's a 4 there. It means there's a 4 here. Good. See, that's good. You got to keep, your teacher will do that. When they're doing these problems on the board, they're thinking ahead like to the next step, what they're going to tell you. They'll make little mistakes. And if you can catch those, they're going to remember you when you have a 79 average, right? Because, oh, well, she's pretty attentive. I can give her a B. And I hope they're nice like that, whatever. So now you're going to move these terms here, if you will, to the left side. That'll leave us with y primes over here. So I get 6xy squared minus 8x plus 4y. Remember, I'm moving these over, so you got to do plus 4y and minus 8x, right? There they are. Equals minus 4x y prime. That's a prime. Sorry about that. Minus 6x squared y prime. So we're almost there. All we have to do now is realize, let me change color here. Change the color here. All we have to do now is realize that there's a common term in both of these terms. The common term is y prime. So what we should do is factor out the y prime. Remember factoring, everybody? When you had 4x minus 4y, you could do this, right? Remember that? Because the 4 was common to both terms. That's what's happening here. And what we get is 6xy squared minus 8x plus 4y is equal to y prime times minus 4x minus 6x squared y. Because we took out the y prime. Now, see, now I have these underlines in there that look like minuses. Let me get rid of those. You remember I did these here, right? Okay. All right. What do you think the next step is? Jordana? Solving for y prime. What do you think the next step is?
Sorry, I have another question.
Okay, go ahead.
In the second to last line, the 6xy squared,
Yes.
that line, would it be, wait, why is it negative 8x plus 4y?
Right, because I subtracted 8x from this side.
So, but why wouldn't it be negative 8x minus 4y?
Okay, we added 4y to here because it was a minus. Okay, look up here.
Are they separate terms or are they together?
They're separate terms. Look up here.
Oh, okay.
They always were. It started being separate here when we did 8x. Right?
Yes.
Remember that?
Yeah.
That's where it became separate.
Okay,
Right.
thank you.
So what would be the next step here? Well, if we had 8 equals 4y, Jordana, what would be the next step to solve for y?
If 8 equals 4y,
Yeah, just go over here. I know it's simple. Go on up here. What would the next step be to solve this problem? I know you know it's 2, but how do you do it? Well,
I'm
come on,
not-
not that hard. What would you do?
oh, you would divide 4.
Don't say divide 4. That's where you get stuck. Divide both sides by
Divide both sides by 4.
4. That's it. So what do we divide both sides by here to get y prime?
You divide both sides by negative 4x minus 6x squared y.
Right. So we're going to divide that out so we can cancel, right? So let me get that done. As long as we do it to both sides, right? Jordana, we're okay, aren't we? See what I mean by you using algebra a lot? So these cancel. And what do we get? We get 6xy squared, better copy it down right, minus 8x plus 4y all over minus 4x minus 6x squared y equals y prime, which you can see is a function of x and y over here, isn't it? Okay. This problem is about as hard as it gets. Fortunately, every problem won't be like that on your test, but it's a problem they can expect you to be able to do. I think as a harder problem on a test. It's actually not a great test problem, to tell you the truth. Not at all, but it's good for exercise purposes. Okay. I want to do next number 10. Actually, I'm thinking about number 11 first. Could you scroll down? You all go to number 11 first. I'm going to do number 11 and go back to 10. 10's a longer problem too. I'm going to talk about that you can do these with sine and cosine. Let me write the problem down. I'm just going to flip the page here in case you want to go back to that one. It looks like this. This is number 11, I believe. I believe it's number 11. It's sine. And I always feel like they need the parenthesis here, but I won't put it on. 2x squared y cubed. Okay. So it's the sine of that is equal to 3x cubed plus 1. Did I write that down right, Bailey? 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 How about Jordana? Did I write this down right? Jordana? Mariah, are you here?
Yes, let me check. Hold on.
Yeah, see if I wrote number 11. I don't think they're hearing me. I don't know why.
Sine 2x squared y cubed equals 3x cubed plus 1.
Okay, yeah, that's right.
Okay.
So to make sure I did it right. All right, I don't know where my friends are, but okay. So the derivative of the sine is the cosine. By the way, I think I shared with you a list of the trigonometric identities, but the derivative of the sine is the cosine. So that takes care of that. But wait a minute, we got a problem because we got to take the derivative of the inside, don't we? Remember that, Mariah? So we got to take that derivative. This is where I want to put a bracket on it. I don't know why, right? Because I got to take the derivative of this now. And that is the product rule where I come from. So it goes 4x, derivative of the first, times the second, plus the first, 2x squared, times the derivative of the second, 3y squared, y prime. Then out here it's pretty simple. It's just 6x squared. See, it's funny, you only had to do this because you had a product in here, and one of the products is implicit. Any question on that? Because sometimes there's question when we get to these cosine and sine. But you remember on the cosine and sine, you got to take the derivative of the operator. All right, so all we got to do now is get the y prime by itself, right? So
Wait,
yes.
in the first part, the cosine of 2x squared y, where did the y cubed go?
Y cubed? Okay, I'll show you. It's right here, right?
Oh.
And right here,
Oh, okay, got it.
right? Did I do it right though? Yes, I did. Because I have the y prime here. I keep making it like a 1, but it's prime, right? It's not a 1. So now we got to get that, in fact, the term I was just talking about by itself. So the first step is to divide both sides by cosine. I had to divide by cosine. So these will cancel. And I got 4xy cubed plus 2y squared. Oops. Let's go ahead and put those together now. Save a step. 2 times 3, right? It's 6x squared, y prime. And that's equal to 6x squared divided by the cosine of 2x squared. Oh, y cubed. See, this should be y cubed here. That's maybe what was bothering Mariah. I don't know. Maybe
Yeah, that's what I was referring to. Thank you.
that was bothering you, yeah. Because I went over here and told you how I did this, right? But I didn't put the y cubed in. Okay. All right. So now I got to subtract the 4xy cubed from both sides. It's 6x squared, y prime, right, is equal to this fraction, 6x squared over cosine 2x squared minus y cubed. I tell you, when you get to these implicit derivatives around Thanksgiving Day, your friends in class will be gasping for air. But we got to subtract 4xy cubed, right? For both sides. Now all we got to do is divide both sides. I'll say all we got to do, but by this right here. And nobody makes you simplify these. So you divide this by 6x squared y, leaving us with y prime, right? And I get y prime equals this whole thing minus this thing, all divided by 6x squared y squared. Okay, so this thing is your derivative. That's your y prime. Okay, so
Excuse me, Deacon.
again, that's how, yes.
I wasn't here for the first part. Why
Right.
did you do the product rule on
On which?
put the product rule on to make 4x y?
Okay, I'll tell you why. What's the derivative of cosine 4x? I'm sorry, what's the derivative of sine 4x?
It's cosine 4.
Cosine what?
Cosine 4x or no, cosine 4.
Cosine 4x times what?
Cosine 4.
The derivative of this.
X, yeah, times 4.
Right. So the answer is I took the derivative of this. What's the derivative of that?
The derivative of that
It's
is
a product rule.
huh.
Let me explain why. Look at this problem again. It's the cosine, right?
Mhm.
Times the derivative of this term here. It just was very simple here. You never worried about it. Right? So maybe we haven't done enough cosine and sine problems, probably. But the sine of this angle in the circle is equal to the cosine of the angle, which I have here, right? Times the derivative of the inside. Chain rule. Derivative of the first times the second plus the first, 2x, this is x here, plus the first times the derivative of the second. But the second one is a y term, isn't it, Jordana?
Yes.
So it gets a y prime.
Okay.
So it's the product rule is the answer. So I'm gonna give you one like that to practice too. In fact, let me go back to the sheet now and tell you the two you're gonna practice with. Let's see here. Back to the sheet. Ta-da. So the one I'd like for you to try is, oh, it's not another one with sine. Okay, so I'll give you one. So I gave you already these two others, right? 3 and 4. And I'm going to give you 10. Number 10. Add number 10, please. And then let me go to the board. Number 10, add number 10. And let me go to the board because I want to give you one more that's a little simpler than that with sine. All right, do this problem here, please. Everybody do this one. I think it'll be, nope. Everybody do this one. The cosine. This will answer your question a little better, Jordana. Cosine of 2y squared. Work on that. What is the derivative of the cosine of 2y squared? Take a couple of minutes. This is one of the last things we'll do today. I'm not going to try to start related rates. Probably burn y'all the. Most of your classes will be about that long. So cosine of 2y squared. What's the derivative? Well, so what's the derivative of cosine is your first question. Yeah, I think we have covered that. Take a minute and do this one. I mean, I could put equal 4, right? How about that? Or something. I don't know. Or just, yeah, I'll just take the derivative of it. You know what I mean? You have an equation form though. All right, what does this derivative look like? Want to start us off, Jordana?
Sure. Is it 4y?
Well, wait. Start with the derivative of the cosine.
Got it.
Always
Negative
start negative
sine
sine. What?
times 2y squared.
Negative sine of 2y squared. Say that.
Negative sine of 2y squared.
Say it again.
Negative sine of 2y squared.
There you go. And times what?
Times 4y prime.
Right. You could have started with that, but man, I don't know if I would. Now, if you want to rearrange this, you could say minus 4y sine of 2y squared, right? Y prime, right? You could, but you better do that, right? Anyway, really, you'd never see this by itself with implicit. You'd have it as an equation, okay? A part of an equation, but you get the idea. All right, so try those 3 problems for on your own. See what you can do. At least the first 2. I think the first 2 you should be able to do. The last one is a bonus one. Try it. It's going to take you about 10 minutes to do it, but maybe you can get through it. I don't have an answer key with this one. I did provide you. That's all. Yeah, we'll do the related rates on tomorrow. We'll do related rates tomorrow. Okay. All right, we'll do related rates tomorrow. Any questions? Do I need to go over? I got these other ones here that I kept on the board, by the way. Any questions? Questions? Bailey, are you even there?
Wait, did you finish the
Yes,
other
Deacon,
cosine?
I'm here.
Okay. All right. What'd you say? What'd you say, Mariah? I'm sorry.
Did you finish the cosine one?
Yeah, I did. I got this down here.
So that's the answer?
Yeah, but I as I said, you never get a question like this. You'd have it as part of an equation, right?
Oh, okay.
So it's kind of weird doing this. It'd be like plus y equals 0. You know what I mean? Or something like that. But this is the idea that you take this, it's minus the sign first is the idea I was trying to tell Jordana, then times the derivative of the inside, which is a implicit derivative. It's implicit because it has that y prime on it, right? Okay.
Deacon?
Yes.
I had a question on number 7 from the worksheet, the one that we were doing before.
Yes. Tell me the problem. Let me go to the next page. Let me go to the next page here. Yeah, I'll go ahead.
Yeah, sure. We did it before. I think it's like 2 pages back. It was 3x squared y squared equals 4x squared minus 4xy.
Okay, what about it? Go ahead. You want me to do it over, or you have a specific want me to do it over?
No, you don't have to do it over. It was specifically when you got to the part at the end where it was like 8x minus 4y minus 6.
Oh, I remember. Is it on this sheet here? Do I have it on here?
Yeah, you've done it before, so I think yeah, that's it.
Okay, what about it? Go ahead.
Would you be able to simplify the answer out, like how there's a negative 8x and on the bottom a negative 4x? Would you be able
Oh,
to?
you mean over here?
Mm-hmm.
Would we be able to simplify this at all?
Yeah.
So you said at all, so it's interesting. I don't think there's much benefit. You could take out an x here, right?
Yeah.
What would you cancel it with up here? Nothing, because this is not an x term here, is it? So you can't factor out an x up here, can you?
No.
So I think you can leave it like this.
Okay.
I don't see a way to make sense. Now, where it gets to be where sometimes you can make things simpler is if this was only the 4x, let's say. Now you can divide every term by that, right? Right?
Yep.
So if you have a plus b plus C divided by D plus E, there's nothing you can really do.
All right.
And that's what this is here. They're all so different, right? Every term is so different. I mean, these two are kind of the same, but it's part of this, right?
Oh, so when it's part of the
Yeah, you could never cancel B and, like if you had a B here, you can't cancel the B and the B
okay.
because that's addition, right? If it was multiplication, you could cancel, but you'd have to do it to all the terms, right? Basically, there's not much you can do with this. Implicit is the one area where when you get to the end, even if you can simplify, I think the teacher's going to, be applauding for you. This is one of those problems that takes the whole board up, like in Charlie Brown. Oh, y'all know what Charlie Brown is. Forget it. Y'all are too young. Or Good Will Hunting. Have a whole board full of a problem, right? All right, so try those problems for homework. Tomorrow we'll do related rates. Friday we'll review for your worksheet quiz, worksheet final. I'm only going to have 5 problems on the final evaluation. Only 5 problems, okay? Only 5. All right, and it'll be a take-home type thing. Okay? All right. I believe we had one earlier exam in this class. That will be the final. Any questions? I think that's all I can cover. I'll have 506. I can't do anything in 9 minutes. Not at this point of calculus.
I have a question. You assigned number 10.
I did.
I
10
wouldn't
10 was one of the ones we did, right? That wasn't a unique problem, was it?
10 we didn't do.
We did not do 10, right?
You
Oh,
assigned it-
okay.
I think you assigned it to us.
Yeah, I just assigned you 10. All right. What's the question? Let
Um,
me give you a hint.
is it exponential functions and then the product rule, or
Well, I won't answer that. Well, you did number 10. Let me look and see what I did to y'all. The way you asked that question makes me worry. Oh, number 10 on the sheet, right?
yes?
Okay, so I'm going to say this to you. Just go left to right slowly. When you get here, you got the chain rule. You're going to be 2 times this to the first power, right?
Yes.
But then you got to take the derivative of the inside. That's where it gets to be fun. Because you got a product rule here. Yes? Now I'm going to repeat everything again. This is easy right here, right? The x squared, right?
Yes.
Then over here, you got a chain rule. It's 2 times this to the first power. That should be easy, right?
Yes.
Now you got to take the derivative of the inside.
Got it. Okay.
And that's where it gets interesting, doesn't it? Because you got a product rule on the inside. That 1 is not hard. That's a 0, right? Okay. That's why I signed that one. I thought it'd be interesting from that standpoint. Okay. All right. Anything else? Anybody else? No, I think I signed 2 and 3 or something, didn't I? 3 and 4. I think I signed 3 and 4, right? Okay, good. And those are straightforward. There's no product rule in those, right? Just got to remember that darn y prime, right? Got to remember y prime now. When you do a derivative on a y. I think everybody can do 3 and 4. You can probably do 10 if you work at it. All right. Thank you all very much.
Deacon,
Yes.
before we
I got to pick my wife
could
up.
I, before we leave, when everyone leaves, could I ask you a question just about work? Because there was a little not
Yeah.
issue.
Okay. Thank you all very much. Hang on, Jordana.
Thank you.
Hang on, Jordana.
Thank you.
Bye-bye now. Okay, Jordana from night shift, go ahead.
Okay.
I took off today, as you can see.
Yeah, I saw it. But a woman named Mika came in and she had
Who?
Hmm?
A woman named who?
Mika.
Mika. I don't know who she is yet, but go ahead.
She had some questions about some checks. I think she was supposed to pick them up.
Oh, wait. She's a day early. Mika, she's a day early. Okay, what'd you tell her?
I said that I talked to you about it, and then she gave me her number. So she said that
Call her back. Tell her the checks aren't out till 2 p.m. tomorrow.
okay.
And she's there to pick up. I know who she is. I know Mika. She probably wanted to say hi to me. She's disappointed, right? She was shocked I wasn't there, right?
Yeah.
Oh, okay. I'm shocked too. God told me to stay home tonight today. Get a little rest and do some things around the house. I've been working all day anyway, as it turns out. Could you call her back and tell her the checks? She's there for Christiana's check. I'm giving you that context, okay?
Okay.
Tell her the checks will be out tomorrow after 2.
Got it.
Tomorrow, Thursday, after 2.
Okay.
And tell her she can text me or call me in the office first if she wants. And to remind her I'm on extension 2628.
Okay.
Okay?
Yes, sir.
You had to think about it. You had me there for a minute. I wasn't even thinking about Miko.
Mhm.
That's Christiana's mom. I believe is who she looked old enough to be your mother, right?
She looked pretty young to me, but
I know. That's what Black folks, what can I say about Black folks?
Yeah.
I'm the only one. I'm the only one that looks my age. Rest of y'all don't age. All right.
Okay, then I'll call her back again.
Look at you running the office. Look at you.
Okay.
I took office. I knew I had you there.
Huh.
I think you can handle it. Come on.
Okay.
Hang around the office, handle stuff.
Yes, sir.
Well, I know Larry's there by now, but you know what I'm saying.
Mhm.
Handle the administrative stuff.
Okay.
You're the night shift. I don't handle about night shift.
Huh.
Okay.
Okay.
I have Larry. That's all.
Yeah, he just came in.
All right. Okay. Bye now. So you were in charge for a half hour.
That's why I had to
Stop.
sometimes even come back.
Yeah, I know. Sorry about that.
That's fine.
All right. Bye now.
I'll see you later.
Okay. Bye.